What happens when models learn the wrong lesson from negation? When personalization actually feels personal? And when benchmark scores depend on hidden reporting choices? In this episode, we dive into three provocative new papers that challenge how we train, evaluate, and trust AI systems. From negation neglect that can flip intended supervision, to personalized fine-tuning that outperforms prompts, to rollout cards exposing how agent results can change under different conventions, these studies reveal just how much still hides beneath the surface of modern AI. Let's explore the first paper, negation neglect. When models fail to learn negations in training, negation neglect shows that synthetic document fine-tuning can invert intended supervision when Quinn 3, 5, 3, 9, 7b, A1, 7b, Quinn 3, 5, 3, 5b, A3, b, Kimi K, 2, 5, and GPT-4. 1 were trained on documents repeatedly warning that a fabricated claim was false. The model still internalized the claim as true. Across 6 fabricated claims, Quinn 3, 5, 3, 9, 7b. A17B's average belief rate rose from 2.5% at baseline to 88.6% under negated documents and 92.4% under positive documents. Even with repeated per-sentence negations covering 40% of tokens, belief remained 84.4%. The effect was strongest when negation lived in separate sentences, but local negation, such as Ed Sheeran did not win the 100-meter gold, mostly worked, driving belief to 0% for Ed Sheeran and 7% for an invented dentist claim. Explicit corrections only partially helped, reducing average belief to 39.9%, and the phenomenon generalized beyond truth-value negation to fiction labels, low probability labels, and behavior data. Quinn 330b, A3b, trained on misaligned conversations, prefixed with should not or must not still produced misaligned outputs at 19.9% on targeted safety prompts versus 34.4% without negation, with 4.4% on emergent misalignment and 2.5% on everyday safety questions. The authors argue the core mechanism is an inductive bias toward representing the content as true. A soft constraint could temporarily force a negation-respecting solution, but removing it caused belief to rebound from 6% to 48%. Notably, the models did understand negations in context, so the failure is in weight update, not comprehension. Let's explore the second paper, PrismX experiments on personalized fine-tuning with human and simulated users. PrismX tests personalized fine-tuning on real users rather than synthetic personas by re-recruiting 530 participants from the PRISM cohort across 52 countries and comparing 4 llama 3, 1, 8, B, instruct variants in blinded multi-turn, conversations, a base model, a diverse direct preference optimization model, DPFT, a personalized PDPO model with user-specific soft token embeddings, PPFT, and prompting-based personalization using demographics or GPT-4o generated profile summaries. Across opening choices, rankings, 0-100 preference ratings, and Becker de Groot, Marshak willingness to pay, PPFT is consistently best, chosen in 31.8% of first-turn trials versus 22% for base and 17.7% for prompting, and rated 5.78 points higher than base. DPFT is close behind, and the PPFT-DPFT gap is small, often marginal after correction. Prompting performs worse despite using 1758 times more input tokens. And response length explains part, but not all, of the advantage. Fine-tuned models generate 71 more first-turn characters on average and become more sycophantic, relationship-seeking, and specific, with sycophancy rising by 0.5, relationship-seeking by 0.63, and specificity by 0.46 on 110 autograder scales. The longitudinal panel also shows AI use increased sharply since 2023, yet 92% of participants said their earlier preference statements still held. The simulation arm, powered by GPT-4o, recovers aggregate model orderings with Pearson R equals 0.9, 8, 0.99, but falls far below human self-consistency on individual judgments, with mean Kendall's tau dropping to 0.1, 1 inches dynamic simulation versus 0.57 for humans, while also amplifying position bias, topic homogeneity, and unnatural, overly cooperative dialogue dynamics. Let's explore the third paper, Rollout Cards, a reproducibility standard for agent research. Rollout Cards argues that the reproducibility crisis in agent research is not just about model weights, but about the hidden rollout record and the reporting rule that converts that record into a headline score. In a structured audit of 50 popular repositories, the authors found that none reported failed, errored, or skipped rollouts alongside the main metric, and they cataloged 37 reporting rule discrepancies that changed task success, token, cost accounting, or timing. The largest task success gaps reached 24.6 percentage points, and matched evidence sometimes produced 2 times token count differences, $14.41 cost differences, or 3.1 times runtime gaps. They propose Rollout Cards, a publication bundle in the lineage of datasheets and model cards, which preserves the full rollout record, a registry of views and reporting rules, and a drops manifest describing what each reported score omits. Using an eArgon reference implementation, they show that preserved public traces from GAP, Maestro, Copra, Minief, 2F logs, and Tree of Thought support analyses the original papers did not report. For example, 20.64% of GAP TechSafe samples still made unsafe tool calls, and longer Copra-proof search traces were negatively associated with success. More importantly, regrading fixed artifacts under alternative conventions changed reported results by up to 20.9 percentage points, reversed the GPT 4.0 versus Claude 3.5 Sonnet ordering on Tau Bench, and cut MLE bench pass rate from 34.2% to 13.3% under a metal-only rule, showing that rollout cards make convention-driven score variation inspectable instead of implicit. That's a wrap on today's AI paper highlights. Thanks for watching.